Welcome to this explainer. You know, the lines between human and machine texts, they haven't just blurred anymore. They've practically vanished entirely. Today we're diving into the ultimate detective's toolkit to explore the incredibly sophisticated techniques being developed right now to distinguish human writing from AI generation. It is quite literally a high-stakes game of cat and mouse, and the tools we have at our disposal are nothing short of brilliant. Let's get into it.
So how can we actually tell if a human or an AI wrote a piece of text? Because let's face it, with large language models generating text this fluidly, we just can't rely on the feel of a document anymore. We need highly technical detection tools to figure out who or what is really behind the keyboard. Distinguishing between human-generated and AI-generated content has become incredibly complex, and that is exactly the core dilemma we're facing today.
Here is our roadmap for today's explainer. We'll start with 1, the AI text dilemma. Move into 2, watermarking generated text. Explore 3, DetectGPT and tracking probabilities. Dive into 4, stylometry and linguistic fingerprints. Look at 5, GPTZero's Perplexity and Burstiness. And finally wrap up with 6, the limits of detection.
All right, Section 1, the AI text dilemma and the inherent fragility of text. Moving right along to Section 2, watermarking generated text.
Think about this for a second. Unlike images or audio where you can easily hide data in pixels or sound waves, text is incredibly fragile. Any embedded clue or watermark absolutely has to preserve the readability of the document. When an AI language model generates a sentence, it picks words based on mathematical probabilities. Watermarking basically intervenes by subtly promoting certain green tokens during this generation process. This means the model is slightly more likely to choose these specific words or phrases, leaving this faint, statistical trail that it was the creator. And the absolute genius of this is that the promotion is done so delicately, you don't even notice a drop in the quality of the text.
And there's a whole arsenal of ways to actually pull this off. We've got zero watermarking, which extracts word frequency for a reference database to check against later. Then there's linguistic watermarking to tweak synonyms, or steganography to subtly alter word order. We can even change paragraph structures with structural watermarking, or alter the broader mathematical frequencies using statistical watermarking. It's pretty amazing how many embedded clues we can hide in plain sight.
Section 3, DetectGPT, tracking probabilities.
Now, if an LLM produces a text, every single word has a specific conditional probability of appearing based on what came right before it. It's kind of like forecasting tomorrow's weather based on today's patterns. By multiplying all these conditional probabilities together, you get a joint probability for the entire text. DetectGPT cleverly uses these log probabilities to spot the AI's underlying invisible mathematical signature.
So how do we test this? DetectGPT takes the original text and perturbs it, which is just a fancy way of saying it makes slight automated tweaks to the phrasing. Step 3, it compares the log probabilities of both the original and the new perturbed text. If the new log probability is significantly lower, well, that strongly suggests the original text was AI-generated. Why? Because the AI had originally selected the mathematically optimal path. If it's not significantly lower, you're likely looking at a human's work.
Let's jump to Section 4, stylometry, or linguistic fingerprints. Stylometry is just a fascinating area of computational linguistics. It turns out that every single author, whether human or machine, leaves behind a distinct and highly quantifiable literary fingerprint. We can analyze features like word length, sentence length, and overall vocabulary richness to attribute authorship. In the realm of AI detection, we use this exact method to identify the distinct style of a particular AI model based purely on its linguistic patterns.
We've got 2 really heavy hitters here for techniques. First is n-gram analysis, which counts specific sequences of words or characters to capture distinctive patterns. And second is function words analysis. Function words like and, the, or is, they carry almost no meaning on their own, right? But humans use them completely unconsciously and highly consistently. Tracking these underlying grammar patterns is a massive giveaway for finding an author's true fingerprint.
And these linguistic fingerprints are incredibly versatile, way beyond just catching AI. Stylometry is used for authorship attribution in historical or disputed texts. It can literally predict an author's demographics or psychological traits just based on how they write. No way, right? It's also used to categorize text by genre or time period. And today, it's heavily integrated with machine learning models like random forests and neural networks to classify massive amounts of text faster than ever before.
Okay, Section 5, GPTZero, Perplexity and Burstiness.
So GPTZero computes a metric called perplexity. Put simply, because AI models are trained to maximize text probability, they naturally minimize perplexity. So the lower the perplexity, the less random the text. GPTZero basically assumes that text with low perplexity is highly likely to be generated by an AI that is minimizing randomness at the wheel.
But it also looks at a behavioral metric called burstiness. You and I, human writers, we are wonderfully chaotic. We might write this massive, rambling paragraph, followed by a punchy 3-word sentence. Boom! Maybe even throw in an erratic typo for good measure. That is high burstiness. AI text, conversely, remains rigidly predictable and consistent in its sentence structure throughout. Checking for this lack of burstiness is an absolutely key indicator of AI.
Finally, Section 6, the limits of detection.
Here is the reality check. The crucial takeaway for anyone using these tools is that they are not completely foolproof. Stylometry can suggest correlations, sure, but it cannot definitively prove intent or authorship. Plus, its results can be heavily skewed by the genre of the text or the heavy hand of human editors. Even conscious changes in an author's style can mask their fingerprint entirely. And on the math side, tools like GPTZero often have to rely on linear model approximations to calculate that perplexity, which inevitably introduces a margin of error.
Ultimately, our goal here is a delicate balancing act, perfectly summed up by this quote. By striking a balance between robust watermarking and text integrity, we can ensure a secure and authentic communication landscape in the era of advanced AI. As we deploy these incredible tools, from subtle watermarks to tracking perplexity and burstiness, we are actively trying to protect the truth and origin of our communication without destroying the readability and flow of the text itself.
We've explored the tools, the math, and the linguistics of catching AI today. But as these language models inevitably become even more sophisticated, and as our detection tools race to keep up, I really want to leave you with this lingering thought. As AI detection evolves, how will we ultimately define what makes communication truly authentic? Thank you so much for joining me on this explainer. Keep digging into these concepts, and I'll catch you next time.